So we had a lot of really great talks here at the inaugural Crossplane Community Day, and we're excited to announce the Upbound Cloud Community Preview from the creators of Rook and Crossplane. Upbound Cloud Community Preview is the fastest way to get started with the open source Crossplane project using free time-limited environments for early evaluation. Upbound quickly gives you an enterprise control plane that layers on top of your existing infrastructure and cloud services, giving you all the tools you need to build your own internal cloud platform the same way industry leaders build theirs. Upbound and Crossplane make it easy to define, compose, and publish your own infrastructure APIs that encapsulate policy guardrails and automation, so it's easy for teams to consume the infrastructure they need, conform to best practices and policies, and deliver applications faster. Let's get started with a live demo. Upbound Cloud supports personal accounts with access to environments, workspaces, and repositories. Each environment provides a dedicated Crossplane instance with a custom infrastructure API for your internal cloud platform. Multiple workspaces can be added to an environment so app teams can self-service from the internal infrastructure APIs you create in each environment. Repositories allow you to publish your own packages to the registry for your teams to use privately, or to publicly share your providers, stacks, and applications with others. Upbound Cloud also supports organizations, which include users, teams, and robots. Users can be owners or members of the organization. Teams can be structured however you like with role-based access control across environments, workspaces, and repositories. And robot accounts can be used from CI/CD pipelines and GitOps workflows. To get started, let's create a dev environment. Okay, so once this environment's created, we'll be able to install packages from the Upbound registry into our environment, including providers to add cloud service primitives to the control plane, and stacks to publish infrastructure abstractions to your internal API for apps to use. If we pop over to the registry, we can see here that we have a free community library for all things Crossplane that lets you discover, install, and publish the resources you need for your next Crossplane project. Providers add cloud service primitives to the control plane in your environment. Stacks configure an environment to provide your infrastructure abstractions with policy guardrails for apps to use. And applications are installed into workspaces and can easily consume the infrastructure they need through custom infrastructure APIs in an environment. Today, we'll be using the GCP provider to add primitive API types to the control plane in our environment for use directly, or to compose into our own custom infrastructure APIs. To see all of the primitive API types that are included in the GCP provider, we can click Show More, and we can see that we have primitive types for databases, caches, storage buckets, and more. So if we pop back over to our environments, the environment should be ready to go. So we can click through on that, and it's going to prompt us to install our first provider. So today we're going to be using GCP, and then we're going to go ahead and install that into our dev environment. So installing this provider is basically going to add the cloud service primitives to the control plane for this environment that can be used directly or composed into your own custom infrastructure APIs for teams to use. And once this is installed, we'll go ahead and then install the GCP sample stack that adds some sample infrastructure abstractions that our Wordpress application is going to use. So after we deploy and configure this provider, we're going to deploy the stack that has the infrastructure abstractions, and then an application, in this case, our sample WordPress application is going to be deployed on top of that that consumes those infrastructure abstractions. And so once this wraps up here in a moment, we'll just pop over and install that stack. Okay, so that completed, and now we're going to go and browse the registry to install a stack. Here we're going to pick the official Crossplane sample stack for GCP to go with our GCP provider, and also install it into our dev environment. So installing the GCP sample stack is going to add infrastructure resources to our dev environment, including networks, subnets, managed service connectivity resources, plus sample infrastructure abstractions for MySQL, PostgreSQL, and Redis. These infrastructure abstractions will be used to deploy or containerize WordPress onto a GKE target cluster and provision a MySQL instance for our WordPress app. So here, basically, we get the configure step, and so we're going to give it a name. In this case, we want to use something unique because we're using a shared GCP project. So I'm just going to call this May 27th Acme Dev 3, and then we'll just use this project here. You'll, of course, want to use your own project for your own environment. We can pick the regions that we want to use. We'll use US West 2. And then we have a script here that's going to generate a provider secret for us. And so you'll just want to go ahead and replace your project ID with the actual GCP project ID that you're using. And so off screen here, this is basically executing this curl bash, and it's generating a GCP service account. And then it's going to go ahead and enable the cloud services for this project. And then it's going to grant permission to the service account to do things like, manage databases and Kubernetes clusters and so forth. And so with that generated, we're going to just grab the values that are between the asterisks on that if you're following along at home, and then drop that in, and then we'll create a new instance. So once this is done, we're going to see some additional resources be created that are effectively provided in this stack. And that's going to include things like the networks, the subnets, the global address, the managed service connection, but also infrastructure abstractions for Postgres, MySQL, Redis, and so forth. And so the WordPress app that we're about to deploy is going to consume those infrastructure abstractions. And so one of the beautiful things about continuous reconciliation and eventually consistent systems is that you can apply your desired state before all of the resources are ready, and Upbound and Crossplane will keep trying until that desired state is achieved. So we can actually come in here now and deploy our applications into a new workspace on dev, even though that infrastructure has not been fully provisioned yet. So I'm just going to call this workspace 1. And typically these will be created for app teams or service teams that are basically deploying applications into these cloud environments. And here we can then go and browse to install the WordPress app just like before, but now this is going to be installing this app into our workspace in the dev environment. And so we'll go ahead and install WordPress. And so installing this WordPress application is going to add additional CRDs to the control plane in this environment to manage new WordPress instances in this workspace. And then, like before, what you're going to see is a dynamically rendered UI form to actually create the WordPress instance resource. So here we're going to go ahead and call this My Cool App. You can deploy any app you like with Upbound and Crossplane. And then we have an option here to provision a new target cluster or use existing target. We're just going to go ahead and provision a new one dynamically. And so this WordPress instance is going to use the infrastructure abstractions in the dev environment to provision the resources it needs and deploy the app into GCP. And so this is going to include provisioning a Kubernetes cluster as well as a MySQL instance. And so now that we see that here, it's going to take a few minutes. So what we're going to look at next while this is going on is some of the additional things that organizations support, users, teams, and robots, as well as some repositories. So repositories allow you to publish your own packages to the registry for your teams to use privately or to publicly share your provider stacks and apps with others. Here we basically have created our own variants of the GCP sample stack called MyCoolStack for Acme. And then if we go and browse this in the registry, you can basically see that it has, Acme sample stack, and there's a really great write-up in the docs for Upbound Cloud. Definitely check that out to learn how to go and package up your own apps and stacks. And we are moving to a new model in Crossplane that supports composition. That's going to basically supercharge how all of this is done. And so that's basically coming soon to these examples. So definitely stay tuned there. The other thing that's supported in Upbound Cloud are users. And so here we basically can see you can have users and you can add new users either as an owner or a member to your organization. And then those basically can be used in teams. And so here we basically have like an app team with some members here. You can also have robot accounts. And so if we go ahead and add a robot account for our CI/CD integration, then it's going to be able to access that. And then you can also create permissions using role-based access control for environments and workspaces. So if we come over here to our dev environment and say, hey, I want to go ahead and give access to this app team, they should be able to view the environment but not edit or manage it. But they should have full admin permissions on their own workspace. So that's how environment permissions are done. Similarly for repositories, and then like we saw, robot accounts, so that you basically can create tokens for GitOps workflows and continuous delivery pipelines. So with that done, we're basically going to pop back over and take a look at our app and see how that deployment's coming along. And so we're going to notice a couple things here. One is that these basically are the infrastructure requirements that say, I want a Kubernetes cluster or I want a MySQL instance. And it's basically going to have a reference to the actual managed resource here that basically is going to be bound to, and then it's going to indicate if it's basically ready for use. And so we can see that that is in fact ready. And then if we come down here to the database, we can see that, whoops, sorry, let's scroll off the screen there. We come down here to the database, we can see that the managed claim is waiting for the managed resource to become bindable, i.e. it's still provisioning. And so if we look at its reference here to the resource, we can see that it's workspace one, my cool app SQL 2JPWR. And then if we basically drop back over to the environment, we can see that a resource has actually been created there in our dev environment for that database. And so here we can basically take a look at that and see that it's pending create, the resource is being created, and in GCP, they can provision clusters faster than they can provision databases, so that's gonna take a minute. But the cool thing that we can also do now is take a look at how you can do everything that we just saw in the UI from the CLI with kube control. So we're gonna pop over here and just go ahead and get this going in our console window. And this is gonna go ahead and set up an environment context so that we can access kube control from the command line. And then if we go ahead and do a kube control get CRDs, we can actually see all of the API types that are in our control plane that basically Crossplane and installing all of the packages from the registry have provided. And so this, of course, includes things like infrastructure definitions, infrastructure publications, all of the OHM application stuff that we saw earlier, as well as our instance for WordPress. And so the other really great thing is that we have nice documentation for, if we pop back over here to the registry and look at our WordPress application, it's going to go ahead and show us that there's a CLI quick start guide. So if you want to get started quickly and then do this from the CLI, this will actually walk you through from beginning to end, everything you need to do. So like what we saw is installing the provider in the stack here, so there are the commands there, creating the GCP account key file, generating that provider secret, and then actually generating an instance of the stack, and then getting the output for that. And then we can skip down to installing the app, where we installed WordPress, and then now we're at a point where we've deployed the app instance, and then we can go ahead and grab this now. And so if we pop back over here and just bring that across, we can see that our app is actually deployed. And then similarly, we can see that we have our resources. And then the database here now is available for use. And so if we come down to look at the application resources that were created on that target cluster, we're going to be able to see that there is in fact that load balancer IP, which should be serving WordPress now. And so if we go back to Upbound Cloud and then pop over to our our application in our dev environment and take a look at our WordPress instance for the service, we should basically be able to see that this is exactly the same resource that we're seeing here in the UI as we can get entirely through the CLI. And so now if we basically grab that IP address, we should see that WordPress is up and running using the Cloud SQL database deployed onto a dynamically provisioned cluster there. And there we have it. So WordPress is up and running. And so now what we can do is clean everything up in this environment. And so it's as simple as deleting the resource, which is the same resource that we created, the WordPress instance for the application. That's going to delete all of the contained resources in this application package. And then we're going to be doing a graceful delete ordering so that all of the Kubernetes resources are deleted first, and those are going to delete the constituent cloud services that are provisioned on behalf of like a Kubernetes service with like ELBs and firewall roles and security groups and that type of thing. And then the cluster gets cleaned up along with the database instance, all the infrastructure. And then once that's done, we can go and delete the environment as well. And so popping back over to the environment for a teardown, we'll just go over here and then we can find the resource that we created for the stack instance, and we can go ahead and delete that. And then that will start tearing down the entire environment. So really excited about kind of bringing all this together with Upbound Cloud and Crossplane. And with Upbound Cloud Community Preview, you get the fastest way to get started with the open source Crossplane project. Build an enterprise control plane that layers on top of your existing infrastructure, giving you all the tools you need to build your own internal cloud platform. Upbound and Crossplane make it easy to define, compose, and publish your own infrastructure APIs that encapsulate policy guardrails and automation, so it's easy for teams to consume the infrastructure they need, conform to best practices and policies, and deliver apps faster. So give Upbound Cloud Community Preview a try using our free time-limited environments for early evaluation. Check out the docs for a guided tour and let us know what you think. Thanks.